Good morning, warriors. Good morning, fourth graders. Welcome to the lesson 3. Today we are going to see a new lesson, and this is the last lesson for the quiz. Remember that I'm going to make quiz the next week. In the next class, we are going to have a meet, and we are going to discuss the 3 classworks. The 3 classwork we are going to discuss in the next meet. Probably is the next Friday. Okay. It's going to be the next Friday, and I'm going to tell you how, and I'm going to post in Google Classroom. Let's go to the lesson and let's do the classwork. This topic is very similar to the last one, but I need you to focus and try to read with me, right? Molecules in motion. This is the topic of the lesson 3. Molecules in motion. How can you prove molecules are moving if you can't see them? This is the question. How can you prove molecules are moving if you can't see them? Mr. Harris walked to the sink and filled a glass with water. He held the glass up so the students could see it. Is this water moving? This is the question, right? He asked. Yes, Tanika answered. I can see it moving in the glass because your hand is not very steady. Mr. Harris laughed. He set the glass on a shelf. How about now? It was moving when you were holding it, Thomas explained. You just set it down, so the water probably has not totally stopped moving yet. Mr. Harris agreed. Let's just leave it there for a while. Then, the next day, Mr. Harris stood by the sink again. He pointed to the glass, which had sat undisturbed for almost 24 hours. Or he left the water there. Is this water moving now? Mr. Harris asked. No way, Louis answered. No one's touched it since yesterday. Mr. Harris opened the drawer and removed a small bottle without touching the glass. He added 3 drops of green food coloring from the bottle to the water. Pay attention, this is like an experiment. I'm reading the experiment, it's like a story, right? The drops slowly drifted to the bottom of the glass. As long as this water is not moving, those drops should just stay at the bottom of the glass, right? It's a question, right? Mr. Harris asked. Everyone agreed. Let's leave it alone, Mr. Harris said, and check it again tomorrow. Okay. The next day, the first thing the students noticed was the green water, obviously, right? Because the drop of the green liquid spread it around, right? So, the food coloring had moved from where it was concentrated at the bottom of the glass. Now, it was spread throughout the water. Mister, look at the picture. This is the position of the water. You can do this experiment in your house if you want. Mr. Harris reminded the students that no one had touched the water from 2 days. He explained the molecules, this is the topic, molecules, right, are always in motion. Repeat after me. Molecules are always in motion, no matter how long the water sat without moving. Its molecules kept bouncing around, even though you couldn't or could not see them. The molecules of the food coloring stay clumped together at first. All the molecules in the glass were in motion through. The water molecules and food coloring molecules were soon mixed together. The green water, this is the title, Mr. Harris pointed out, is our proof of molecules in motion. So, classwork. We are going to answer the different questions. Circle the letter of the best answer to each question below. Number 1. Atoms and molecules are in motion sometimes, always, rarely, almost always. You know the answer, right? Mr. Marvin, read this story that is an experiment about molecules. So you're going to know what's going on with the molecules. Remember, molecules always are in motion, motion, motion. Mr. Harris, let the water sit still for 2 days because, option A, he wanted to be room temperature. Option B, he needed time to buy food coloring. Buy food coloring. Option C, he wants only molecules to be moving in the glass. And option D, he needs some of the water to evaporate. This is the answer. I think it's the option C, right? He wants only molecules to be moving in the glass. The experiment was this. It was the idea of the experiment, right? So the water, number 3, the water appeared motionless to the students because option A, molecules are too small to see. Option B, the glass was sitting on a high shelf. Option C, the water did not have any color yet. And option D, it was very cold. Again, the water appeared motionless to the students because molecules are too small to see. The glass was sitting on a high shelf. The water did not have any color yet. It was very cold. You know the answer, right? Number 4, which of these variables do you think will most likely change the result of the experiment? Option A, using red food coloring instead of green. I don't think so. I think it's the same. Doesn't matter the color. Using bottled water instead of tap water. I don't think so. Use ice instead of water. Maybe. Use a different size glass. I don't think so. So, which of these variables do you think will most likely change the results? I think maybe the bottle instead of the tap water, or using ice. I think using ice is the answer. Okay, we continue. The last one. Write your answer on the lines below in your own words. Okay, your opinion, right? Explain why the food coloring move around in the glass. Remember the molecules, right? The process of the molecules, they are always in motion. So this is the experiment to see that molecules are always in motion. Okay guys, this is the classwork. This is the lesson number 3. See you the next Friday in the meet, and we are going to discuss the questions and prepare for the quiz of the next week. Thank you so much. Behave.